So let's talk about it. Let's talk about logical operators. As we said earlier, logical operators are used in conjunction with Boolean expressions. There are three fundamental logical operators. The not operator, which is represented by the exclamation mark. The and operator, which is represented by double ampersand. And finally, the or operator, which is represented by double pipes. But what does the not operator do exactly? The not operator, as we said earlier, is represented by the exclamation mark. It takes in one operand. It inverts the operand to its opposite value. It returns false if the input is true. It returns true if the input is false. The and operator, on the other hand, is represented by double ampersand. It takes in two or more operands. It combines and returns one single Boolean value. As we can see in the truth table, it returns true only if all operands are true. It returns false if at least one operand is false. So how do you read this truth table? Let's take a look at the first line. False and false equals false. On the second line, false and true equals false. True and false equals false. And only true and true equals true. This operator is very easy to memorize. It only yields true if both operands are true. Now, the or operator is represented by double pipes. It takes in two or more operands. It combines and returns one single Boolean value. If we look at the truth table, we see that the or operator returns true if at least one operand is true, and it returns false only if all operands are false. Let's take a look at the truth table. False or false equals false. False or true equals true. True or false equals true. True or true equals true. This one is also very easy to memorize. It will only return false if both operands are false. Here are some examples of how logical operators can be used in computer programming. When evaluating Boolean expressions, we kind of have to start from the inside out. Let's take the first one for instance. 3 is less than 5. That is a true statement. That is because 3 is actually less than 5. We are, however, using the not operator, which inverts the result of the targeted Boolean. 3 less than 5 is true. Then we flip it, the result is false. Now the next one is a little more complicated, as we seem to have two Boolean expressions combined with an AND operator. Let's evaluate it. 1 less than 2 is true. 3 less than 4 is true. According to the truth table from one of the previous slides, true and true is true. So that one is correct. It's true. Now I invite you to pause this video and work on the next 3 examples. See if you can come up with the solution for these. Okay, if you answered false, true, and true, you are correct. Congratulations on the great work. Now, if you missed 1 or 2 here, don't worry, it's perfectly normal. This is a very complex subject and it does take a lot of practice to get the hang of it. My advice to you here is, go back to the beginning of this video and give it another go. Hopefully, things will make more sense to you the second time around. A quick note on this slide is about comparison operators. In most programming languages, they are used to compare numeric values. In fact, these are the same exact operators used in mathematics, It's just that programming languages have a different representation for them. When comparing if two numbers are the same, we typically use the double equal operator. When comparing if a number is less than another, we use the less than operator. We can also compare if a number is less than or equal to another number. In that case, we use the angle bracket followed by the equal sign. Of course, we can also compare if a number is greater than another number. In that case, we use the greater than sign or angle bracket. And finally, compare if a number is greater than or equal to another number, in which case we use the angle bracket followed by the equal sign. Something to keep in mind is also that the AND operator has precedence over the OR operator. Much like in math, multiplication has precedence over addition. That explains why in the last example of the previous slide the result was true. That is because the AND operator has precedence. In the end, the solution is 1 greater than 2 is false. I don't even have to look at the second half here because I see these expressions are to be calculated with an AND operator. That only yields true if both sides are true. Because 1 greater than 2 is false, I already know that the first half of the problem yields false. Then I have an OR operator, and the next Boolean expression is 1 equals 1, which is true. According to the OR truth table, false or true equals true. Again, there's no need to get overwhelmed by this. It is a difficult concept, but it does get easier with practice. Feel free to go back and watch this video again as many times as you need until everything here makes perfect sense to you. Something to keep in mind too is that logical operators can be combined in order to make other logical operators, such as the NOR, which is the combination of the NOT plus the OR, NAND, which is NOT plus AND, and then we have the XOR and XNOR, which is exclusive OR and exclusive NOR respectively. I do recommend you do your research on these as they are very important as well. For this course, however, we won't need them too much, so we can just skip them for now.